Questions come up as to what atoms get the double bond, or if we needed to, what atoms would get a triple bond if there's more than one atom to choose from. For example, in sulfur dioxide. In sulfur dioxide, the Lewis structure would have a doubly bonded oxygen and a singly bonded oxygen on a sulfur atom. The question is, why this oxygen and not this one? A Lewis structure is actually representing how the electrons are being shared between these atoms. Now we're using a symbolic representation of lines and dots. In reality, these electrons exist as a cloud of electrons around all of these atoms. So in a sense, saying that a double bond or a single bond is on any one atom isn't necessarily correct. In reality, this double bond and this single bond exist as a hybrid of the two. One way to think of it is that this double bond actually switches back and forth between these two. To represent that, we actually draw a second Lewis structure with a double arrow between them to represent that the double bond switches back and forth. Now, as I said, that's not actually what occurs. What actually happens around this molecule is that the electron cloud is just going to have a higher density where the bonds would be located than where they're not. So these two areas here represent where the chemical bond is. Which one of those represents the double bond and which one represents the single bond is actually kind of irrelevant. Because this is an electron cloud and the electrons are free to move around within it, we can essentially say that these electrons are what we call delocalized. So they are constantly moving around within this electron cloud. So the electrons that are being shared, we see are delocalized, meaning they're not located in any one specific location. So that they're able to move around within this area of probability. The resonance structure that we saw earlier helps to represent that. It's not correct to say that the double bond is here and then it's here and then it's here and back and forth. The correct answer to the question is where's the double bond is that it's spread out throughout here. If you do experiments with sulfur dioxide, you will find that the length of the bonds between these two atoms are exactly the same. The thing is that the bond length between the oxygen and sulfur is a little bit less than a single bond's length, but a little bit longer than a double bond's length. That means that we are literally a hybrid of a single and double bond between these two oxygens. Let's look at another compound. I don't know if this compound exists, but let's just say that it does, and that the sulfur is going to be in the center, and we're going to have an oxygen and the selenium bonded to that sulfur. Now, our Lewis structure for this is going to look just like the sulfur dioxide. We need to have a single bond and a double bond to represent the Lewis structure. So which one gets the double bond? Well, again, the answer in this case is that both or neither. To draw the Lewis structure out, this would be one structure, but to represent it properly as a Lewis structure, we would then put our double arrow and then redraw the Lewis structure so that we just have a single bond on the selenium and a double bond on the oxygen to represent that this molecule is actually some hybrid of both of these. If we look at it in terms of the electron cloud again, the electron cloud is going to be around all of the atoms with a little bit higher density where the electrons are going to be shared between the oxygen and the selenium with the sulfur. So this high dense area represents the bonds. The electrons, since they're free to move around within that area, don't have a specific location for the single and the double bond. We call this resonance. These are resonance structures, and they represent the fact that the electrons are delocalized. They don't have a specific area around the atoms.